Hey everybody, welcome back to another fun and exciting geometry class. Today we are going to be in lesson 2.32. It's called Inequality Axioms, and it is on page 120 in your book. Page 120, lesson 2.32, Inequality Axioms. We've already talked about some axioms, but those axioms that we talked about were what's called equality axioms, or about equal parts. Now we're going to be talking about unequal parts. For example, something that is greater than something else, something that is less than something else. And so there's 4 axioms that we'll be going over today. Okay, let's read axiom 10. It says, if equals are added to or subtracted from unequals, the result are unequal in the same order. What does that mean? Well, if I take a number and equal, let's say I take the number 4 and I say 10 minus 4, and it says that it is the same, so we're going to keep the sign the same, is greater than 8 minus 4. Notice that I took equals. And the axiom says that you can do it with subtraction or addition. It says both. So we'll start with subtraction, and then we'll do one quick with addition too. All right, so what do I get? Let's just do the math, and let's see if this axiom is actually true. All right, so 10 minus 4 is 6, is greater than 8 minus 4 is 4. 6 is greater than 4. It's true. Notice that my interval didn't change. All right, so how much bigger is 10 than 8? Okay, 10 is 2 bigger. On the number line, for example, it would be 2 spaces bigger, 2 numbers, 2 digits bigger. Okay, now look at this relationship, 6 and 4. 6 is 2 bigger than 4. So if I'm adding or subtracting equals, what's going to happen is that interval between the two numbers, 10 is 2 bigger than 8, and 6 is 2 bigger than 4. So it remains a 2-number interval between the two numbers. That's something interesting to kind of keep in the back of your mind. Let's say, well, let's just change that to add now. Let's just add those. Okay. 10 added to 4, or 4 added to 10, I guess better said, is 14. And we keep the sign the same, that's what the axiom says, is 8 plus 4 is 12. So there we go again, 14 is greater than 12, and we still maintain the 2-number interval right there. It is 2 digits bigger than 12, okay? So it's 14, 15, 13, 12, so 2 digits on the number line, for example, bigger. All right, very good. Let's skip down there to the next one, axiom number 11. Axiom number 11 says, if unequals are multiplied or divided by equals, the results are unequal in the same order. Let's do multiplied. Let's stick with the 4, okay? That way we're consistent all the way through. We're using 10 and 8. 10 is greater than 8 again. So now let's say 10 times 4 is greater than, because it says that the results are unequal in the same order. So let's keep the unequal sign the same, and we're going to keep the order the same, as 8 times 4. 10 times 4 is 40, is greater than 8 times 4 is 28. Well, we have the same order. 40 is bigger than 28. All right, notice in this one, the interval changed. Here, the interval was 2 digits, okay? 10 is 2 bigger than 8. But down here, the interval is quite a bit bigger. The interval is actually 12 right there. And so that's interesting just to kind of look at. The reason why is because we're multiplying now instead of adding. Same thing would happen if we were dividing. The interval would actually get much smaller because we're dividing. When we multiply, the interval gets much bigger between the two numbers. But what stays the same is that the first number still remains bigger than, greater than the second number. Okay? So if you start with the bigger number is greater than the smaller number, that's what you're going to finish with if you are multiplying or dividing by the same number in equal. In this case, we used 4. All right, axiom number 12. Axiom number 12. It says, if unequals are added to unequals of the same order, the sums are unequal in the same order. So let's start off with our 8 and our 10. And now this time we're going to add unequals of the same order. What does that mean? So let's add 4 to the 10, and let's add 3 to the 8. So we're adding a bigger one here, and we're adding a smaller one here. Just like we had it set up here. Bigger one first, smaller one second. Bigger one first, smaller one second. So we're going to add unequals. So what do you think is going to happen? Well, if I say 10 plus 4, and it says there in the axiom that they remain unequal in the same order. So 8 plus 3, so this one is 14, is greater than 11. So look, 14 is bigger than 11. Now again, the interval changed a little bit differently on this one because now we're adding unequals. And so make sure that you pay attention there. And you're going to see this in geometry. When are you going to see it in geometry? You're going to see it when you have two triangles, maybe two line segments being added to each other. They're different sizes. One's bigger than the other. But you maintain, here's the important thing in geometry, you maintain the relationship. It stays greater than. Okay, this does not change. So in the first one, axiom 10, no change in the relationship. In axiom 11, no change in the relationship. Axiom 12, no change in the relationship. Now we come down here to axiom 13, and we do have a little bit of a change in the relationship. It says, if unequals are subtracted from equals, okay? So from equals, so now we're going to say 10 equals 10. And so it says, if unequals are subtracted from equals, all right, let's say 4 is greater than 3. So let's subtract the 4 from this equal and the 3 from this equal. Let's see what that looks like. 10 minus 4 is, well, we don't really know right now. Then 10 minus 3. Now, if you look at axiom 13, we can fill in that box. We can put what sign it is. It says the remainders are unequal in the reverse order. So what does that mean? That means we take this sign, in essence, right here, this greater than sign, and we're going to flip it, so now it's going to be less than. Okay, now this is with subtraction, only subtraction. With addition, it would remain the same, but we reverse it with subtraction. 10 minus 4 is 6, is less than 10 minus 3 is 7. Is 6 less than 7? Yes, it is. Okay. Now, I'm showing you with numbers so that hopefully when you get to, because a lot of times you're just going to get stuff like in geometry, you get stuff like this. You get line segment AB is greater than line segment CD. Okay, and then it says, what if we add line segment EF? Well, if we do that, add it to both, we would get AB plus EF. We would maintain the same. Why? Because this is equal to itself. It's an identity. And so it would maintain that, and then we would say that it is greater than CD plus EF. And that's how this is going to work out in geometry. We're not going to be using numbers very much. We're going to be using letters. And obviously this would all be line segments over top of it. Okay? All right. Hope you learned something from that lesson. In the very next lesson, 2.33, you're going to be practicing those things by doing those proofs, going through those exercises there of using these concepts. Basically, in all the proofs, all the exercises on 2.33, you're going to be using one of those 4 axioms, axiom 10, 11, 12, or 13. Okay? All right, we'll see you later. Bye-bye.